Everyone, today we're going to be looking into some insights from Professor Barbara Oakley's book, A Mind for Numbers. We're going to talk about why we put things off, how distractions play a role in the way we learn, what chunks are in studying, the difficult parts of both math and science, and why context is important when we are solving problems. It's all about just understanding how we learn best. So let's get into it. So, starting off, something we all do from time to time is procrastination. And taking a page from Professor Oakley's book, we can break down why we tend to drag our feet when it comes to difficult subjects. So, procrastination, some people think, is just being lazy. That's not always the case. It's when we actively delay something that feels tricky. Have you ever faced a hard math problem and thought, I'll do this later? That's your brain just trying to avoid doing the hard stuff, save itself some stress. The reason we do it is, the way she puts it, our brains have two modes of thought. One is when you're laser focused in, thinking about the task at hand. And the other is more just when you're chilling out, doing nothing, more of a recovery time. And when things get difficult, even when you're in that laser focus mode, our brain tends to switch into chill mode to try to save it some stress and give it some time to recover. But how does putting things off hurt our learning? Time is the main issue, because when we put off assignments, we end up cramming last second, which is not great for remembering stuff long term. Studies show it's actually one of the worst ways to learn stuff long term, even though it might help you for a test the next day. But it also causes a lot of stress, which I'm sure everyone has experienced with procrastination. Those last second rushes are just not fun, and they make it even harder to get things done and end up creating more stress, which you were initially trying to avoid by procrastinating. But there is hope. Oakley dives into something called the Pomodoro Technique, which is sort of like a game. You choose something that you have to do and focus on it for 25 minutes uninterrupted, and then you take a 5-minute break. Do that over and over again. So the way it works is it forces you to think every time you have to do that 25-minute stretch, you only have to do it for 25 minutes, and then you get a 5-minute break. It takes a lot of the load off, and it makes it feel a lot easier by breaking it up like that. So, moving on, we can go into another big issue when it comes to studying, distractions. Similar to procrastination, can cause procrastinations, but is separate. So, if you've ever tried to solve, let's say, a difficult math problem, you realize how fast distractions will come in. Someone will walk in, tell you something, and suddenly you're doing something entirely different. So, leading into that, we can look at what the most common culprits are for distractions. Number one, at least for most people, is technology. That phone lighting up, those notifications, easy distractions. So, and another issue is outside noise, whether that is chatter, music, or just a TV in another room. And the third, but not least, is our own thoughts. Have you ever started studying and remembered that unrelated thing from just a while ago? Yeah, everyone's done it. Or just thinking about anything in general can cause issues. But there's a twist to it, which Oakley brings up. Um, she she says in her book that distractions may not always be bad. Most of us think, of course, they're bad. I mean, they distract you from what you're trying to accomplish. But it's a little bit more complex than that. Sure, if you're in that deep focus mode, um, trying to understand like a new concept, then, those interruptions, they pull you out of the zone. That's a downside. Very obvious. But when you remember that our brains have two modes, and you realize why our brain has that chill mode, it is a recovery mode. So sometimes letting our brain wander a bit, letting it get that little bit of recovery, can help us process a lot of the stress. And then when you get back into it, you feel better, and you feel ready to learn more. Because one thing your brain does when it is in that recovery mode is it does a little bit of background processing, kind of logs it into that memory. So when you get back to it, you're more likely to remember it if given a little bit of a break. So distractions are not always the enemy. It's really just about balance. Recognizing that sometimes we need to focus in, lock down, and other times we need to let ourselves diffuse. A useful tool that can help with that kind of thing is chunks, which Oakley goes over, and explains that chunks is a way of organizing sort of a playlist related to a certain theme. Your brain tends to store like-minded ideas in one kind of area. They relate to each other. So when you get new information, it tries to relate it to something else, which relates to something else, and then goes into this little network of related things. So when you first learned to tie your shoes or play an instrument, it felt like a ton of steps, but eventually it kind of just lumps into one. So when you tie your shoes, you're not thinking about which way you're knotting this one, which way you're tying that. You just do it. It's natural. You just think, I'm tying my shoes. It's because your brain's processing it as a chunk, which you can access instantly. Access a part of it, you've got it all. It's easy. It's related in your mind under a neural network. But, that's just because of the biology of our brain. It is neurons making connections with other neurons millions of times over, and with millions of different neurons. So the more you organize and tidy up this room that is your mind, the easier it becomes. So using chunks and recognizing that your brain uses stuff in chunks makes you realize that instead of learning just random bits of piece of information, you should apply it and relate it to other things that you already know. It becomes easier that way. It definitely helps. So that relates to another issue called cognitive load, which, if you imagine your brain capacity as a cup, then every piece of new information is like pouring in water. If you pour in too much, it overflows. You get overwhelmed. But those chunks, which we talked about before, are like little ice cubes. They condense the water into a more compact space, meaning your cup can take more information before spilling over. So when we talk about chunks and cognitive load, we're just talking about how not to overload the brain. So it really is just a core principle of how we learn and how humans process information, which can help you in subjects, especially like math and science, which sometimes feel like they're in a league of their own when it comes to challenge. Which leads us into the subjects of math and science, and why do they feel so hard? Why does problem solving in that aspect feel so difficult for us? Is there anything inherently difficult about them? The short answer to that is yes. And it's not because they're designed to be difficult. There's method to it. It's the whole point of it. It's foundational to nature, it's foundational to the universe. But the best way to do it is you need to learn it from the ground up, as if you were building a building. You gotta learn brick by brick, from foundation up to the top. You can't start with harder stuff. That doesn't make any sense. If you can't do calculus without knowing algebra. You can't do algebra without knowing how to count. I mean, it's ridiculous. So that's why it's really important what you learn from a younger age, because each formula is like a building block to that. When you miss something, you become a little bit less structurally sound. So the reason it makes that's one of the main reasons it's so tricky for students, especially, as opposed to more abstract concepts like history or English, in which you can learn some parts and you don't have to really know other stuff that happened for it to interfere with that. Like, you can know a lot about American history without knowing anything about the War of 1812. But that's because it takes a lot more memorization and less problem-solving skills. So there's less to apply to it. 'Cause I feel like anybody could be good at history. All you do is memorize information. Math especially also takes a lot of precision. A tiny error can mess up the whole thing. If you were driving over a bridge, you hope that the engineer was good enough to not make those little errors, or else the bridge might collapse. And it, in general, just has a big fear factor to it. There's a mental block that comes with these subjects. Everybody thinks of them as exceedingly difficult, and therefore they are. It's a trap that a lot of people tend to fall into. It's a real thing. It's been coined math anxiety. And it's real. And it makes the challenge even steeper. So it's not just you. Science and math will come with their unique set of challenges, but there is a silver lining to it. Understanding this is half the battle. And recognizing it means that we can create strategies and tackle them head on. It's like going up a steep mountain. Looking up to the top of that mountain seems impossible, but it's just one step at a time. It's conquerable. So finishing off, we're going to talk about a topic that's crucial when it comes to learning. Probably one of the most important. It definitely relates to chunks and neural networks, all of that, but that is context. It's the setting, the background, and the environment of which a piece of information exists. It's the way your brain makes its connections. So to break it down in understanding why context is so important, just imagine somebody handed you a piece of a puzzle, and it has some color. It's a tiny piece of an image. You have no idea what the rest of the image is. You may remember, oh, it's a little blue piece of a puzzle, but it doesn't help you with anything. But the more puzzle pieces you get, the more it fits together, and then suddenly that puzzle piece that seemed insignificant has its significance. So fitting it into the whole scheme of the puzzle, it gives it significance, which it doesn't have on its own. Our brains love patterns, it loves pattern recognitions, and it loves making connections. So when we learn something out of context, when we learn that little puzzle piece, our brain tries to anchor it to something we already know. It tries its best, but if it can't, it would rather just forget it. It doesn't want to leave it hanging there if it can't create a connection or create a chunk. And that leads to the question, how can we make sure that when we learn something, we're getting the full picture and not these random pieces? Well, the best way is active learning. It's not just sitting there listening. You question it, you look into it, and you try to fit it into the context. Another way is group study, because it encourages communication about the subject and hearing the other ideas about it with other people. And the final way, if not the best way, it is to teach it. Because to teach something means you know it inside and out. If you can explain it in a shorthand way to other people, you know it. So, wrapping up, context is not just a backdrop. It holds our learning together and turns these puzzle pieces into the puzzle, which will help you learn not just in whatever class you're stressing about, but in everything in the future. So, think about what we've covered: procrastination, distractions, chunks, challenges of math and science, STEM fields, and the importance of context. Learning these things can be crucial for helping you learn in the future and can just help with efficiency. They're tools that help make a learning journey smoother. You don't need to overcomplicate anything. You don't need to overflow your cup. You don't need to get overwhelmed. Once you understand how your brain works and understand that it does need rest and it does need recovery, you can implement these strategies to help move forward and do better overall. So keep these things in mind and remember it's about growing, piece by piece,